Kia ora koutou. In this video, I'm going to go through question 3e from this year's complex numbers exam. So I think this was definitely the hardest of the three excellence questions, and I think I don't particularly like this question. I'm going to do it two different ways. The first way is the most efficient way that I've found so far to do it, but I don't think that that's what I would have seen as a year 12 or 13 sitting this exam. And then I'm going to do it the way that I did it before I saw the nicer way. For those of you who just want the answer is k equals 4. Okay, but let's have a look at how I started it. So first of all, I just read it carefully, and we're given this little equation about z, and k is a real number, and then we're told that w over z is equal to 2 plus 2i, and we know that the imaginary part of w is 8. So it actually doesn't look that bad when you read this, it's just that it gets kind of messy. So if we just write it out, we've got z plus 2i is equal to iz plus k, and then we've got w over z is equal to 2 plus 2i. So I'm going to start out by giving a real and an imaginary part to each of z and w. So we'll say let z equal a plus bi, and let w equal c plus 8i, right? So I don't have to do d here because I know that the imaginary part of w is 8. So we can plonk that into our problem straight away. So what have I got now? Well, I've got A, B, C, and K. So I've got 4 unknowns, which is quite a lot of unknowns. So I think my strategy when I did it the nice way was to go, all right, I am just going to find ways to eliminate things as fast as I can. So I started off with using this equation and going as far as I could with this one, and only then starting to work with this one here. Right, so z plus 2i is equal to iz plus k. Substituting in, we get a plus bi plus 2i is equal to I times a plus bi plus k. So my strategy here is going to be to collect up the real parts and to collect up the imaginary parts. So on the left-hand side, we get this, and over here, I get, for the real part, k minus b plus ai. Now, that means that I can start to equate the real and the imaginary parts, and that's the strategy that I'm going to use over and over in this question. So we've got a is equal to k minus b, and we've got 2 plus b is equal to a. All right, so what's the first thing that I can do with that? Well, here we can, so for this one here, we can say that 2 plus b is equal to k minus b, which tells me that 2b is equal to k minus 2. b is equal to a half k minus 1. We're going to pop that into a little box. And the next thing that we can do is get an expression for a. So a is equal to k minus a half k minus 1. And so a is equal to a half k plus 1. We've lost a k in there. There we are, half k plus 1. So what I've done now is I've got expressions for a and b in terms of k. So that means that I've eliminated 2 unknowns. Let's go back to the first part of the problem. We've got w over z is equal to 2 plus 2i, and w is equal to c plus 8i. So I'm going to start substituting in here, and this expression is going to have c's in it and k's in it, but it's not going to have any a's and b's. So we've got down to 2 unknowns now, c and k, and we should be able to solve for both of those things because we've got a real part here, which is 2, and an imaginary part, which is also 2. So that's kind of where I'm going in my head. So let's write this out. We've got w over z is equal to 2 plus 2i. So w is c plus 8i, and z is a half of k plus 1, plus b, a half of k minus 1, I is equal to 2 plus 2i. Now there are a few things that you can do here, and in the second way that I do this, I'm going to do what I often would do when I've got division, and I'm going to multiply lots of things by the conjugate. But in this case, it's actually much easier if you don't do that. What I did instead was this. I said c plus 8i is equal to 2 plus 2i and I wrote that as 2 times 1 plus I, just because I noticed that common factor, times z. Right, and z is a half k plus 1 plus a half k minus 1 I. Now I'm just going to expand this out, and I'm going to collect up the real part and collect up the imaginary part, and then I'm going to do some matching. So we'll give ourselves a bit more space. C plus 8i is equal to 2 into, right, carefully multiplying through the 1, I'm going to get a half k plus 1 plus a half k minus 1i, and now I'm going to multiply through by the I, so I'll have plus I times a half k plus 1. Now I've got my I squared, so it's going to be minus a half k minus 1. And now we can gather up our real stuff. So we've got this bit here, and we've got this bit here. I'm going really slowly here. It would be fine, I think, if you were doing this to skip a tiny bit of this, but if you do that, you're much, much more likely to make mistakes. So here, for the I bit, for the imaginary bit, what have we got? A half k minus 1 plus a half k plus 1 I. So this is suddenly starting to feel very achievable. So C plus 8i is equal to 2 times, right, well this and this go away, 2 times 1 plus 1 is 2. Here we've got a half k plus another half k. So look at that, we've got C plus 8i is equal to 4 plus 2ki. That tells us that 8 is equal to 2k and k is equal to 4. It also tells us, by the way, that c is equal to 4, but we weren't asked for that information. So that's the first way to do this problem. I completely understand if you decide that that's 7 minutes of your life you're never going to get back, but I'm now going to do this the other way, which is the messier way. Okay, just let me find all my bits of paper. Right, and I think this is the way that most strong level 3 students will have approached this question. And that is to start with working here and to solve for z and to go from there. So that's what I'm going to do now. Okay, so we start off with z plus 2i is equal to iz plus k. And we get z into 1 minus I is equal to k minus 2i. So z is equal to k minus 2i over 1 minus I. So notice that in this method, I haven't explicitly written a plus bi out, right? But that's hopefully going to fall out. So z is equal to that. And now we're going to multiply by the conjugate. And if I do that, I get in the denominator, I get 1 plus 1 is 2. And in the numerator, I get k minus 2i plus ki minus 2i squared, which is plus 2. So z is equal to a half of k plus 2 plus a half of k minus 2i. Now, if I look back, I actually hadn't realised, but that is exactly what I had, except that I've just left it written like this, right? So that's basically the same as my first few steps, but done a different way. So that's fine. And then the next thing that you could say is that w over z is equal to c plus 8i over a half of k plus 2 plus a half of k minus 2i. And we know that that's equal to 2 plus 2i. So I'm going to clean up. I don't really like having these halves here. So I'm going to write that as follows. We're going to have 2 times c plus 8i over k plus 2 plus k minus 2i. So I'm actually just going to park this for now. I'm just going to manipulate this expression. And then the obvious next step here is to multiply by the conjugate. Right, so just do our usual steps when we're doing division of complex numbers. And you can see that we're getting down to an expression in C and K, but it's getting kind of messy already. Let's clean up the denominator first. I've got K plus 2 squared plus this plus k minus 2 squared. I'm not going to do much with this because often when we're doing harder problems, the denominator will fall out. Fine if you expanded all of that now. And then what have I got here? Well, I've got 2c, I'm just going to rewrite this, 2c plus 16i times k plus 2 minus k minus 2i. Right, now expanding that top line, what have we got? We've got 2c times k plus 2 plus 16 k plus 2 times I minus 2c into k minus 2i. And then I've got this last term here, this one times this one gives me plus 16 into k minus 2 over all of this. And I'm not loving this, it's a bit messy. Now cleaning up here, what do we get? Right, 2ck plus 4c plus 16k minus 32 for the real bit plus 16k plus 32 minus 2ck minus 4i. And I'd better check that I haven't mucked that up. So just go back and check your last line. So that looks, something's gone wrong there. 16, hang on, 16k plus 32 minus 2ck minus 4c. Right, very easy to get that wrong. So I only found that by checking, and that should be a plus and not a minus, right? And we've still got this painful denominator. But what we can say now is that this whole thing is equal to 2 plus 2i. So from here, the strategy is pretty clear, but the algebra is still a bit mucky. That means that we've got this 2ck plus 4c plus 16k minus 32 over all of this. Is equal to 2. Right. But I can also say, when I look at this, I'm not going to do anything with that yet. I'm also noticing this. And then I'm noticing that these are both 2, so I'm going to use that. So 16k plus 32 minus 2ck plus 4c over k plus 2 squared plus k minus 2 squared is also equal to 2. Now that's great because it means that these things are both equal to 2, and because the denominator is the same, we can just equate 2ck plus 4c plus 16k minus 32 is equal to 16k plus 32 minus 2ck plus 4c. Some stuff disappears, thank goodness. We've got 2ck, what else have I got? A 16k is going to lift off both sides. 2ck minus 32 is equal to 32 minus 2ck. Adding that together, we get 4ck equals 64. So k is equal to 16 over c. Now that's good because we know that the real part of this thing here, so where's my real part? My real part here is equal to 2, and we can substitute back in for k. Now I've got 1 minute left to do that, so I'm just going to tell you that what we end up getting is a cubic. Now for any maths teachers watching, I am not saying that this is the best way to do this question, right? But I'm trying to get into the heads of students who might have kind of gone down the rabbit hole reasonably successfully and just kept on doing the obvious next step. And it does work, it's just a huge amount of work, right? So in here, putting that back into the real part, we get 2c times 16 over c plus 4c times 16 over c minus 32 over this thing here, which I definitely actually can simplify before I go any further. So bottom line is 2k squared plus 8 when I look at it, because I've got some 4k terms disappearing. So that has to equal 2. Right, I've only got 15 seconds left, so once we work that through, we get a cubic, and then we can use the factor theorem to get k is equal to 4. Thanks for watching, and let me know how you guys did this question. I'll finish off the other level